Yeah.
Okay. Good afternoon, everyone. Thanks for joining our bi-weekly all hands PM meeting. We are trying to follow a format where we want to bring one speaker per month, if at all possible. So we'll continue that format for rest of this year, and we'll continue to get good speakers, looking at project management from a different lens and different industry. Today we have Konstantin Badigan, Professor Konstantin Badigan, from joining us today from Nice, France. And let me pull up. Go ahead. The topic for today would be looking at a multi-year project which has, project fuzzy scope, and we do have some of those type of projects where we run it over multiple years, and how do we manage scope? So this is coming from our PM knowledge area of scope management. We'll follow the same format, fireside chat format with questions. If you have any questions, please post them in the chat or raise your hands or just ask it. It's very informal, and Ian will help us moderate. Just to give you a brief background on Konstantin, he's a theoretical astrophysicist whose research primarily focuses on the planetary astrophysics, especially in the formation and evolution of systems throughout their lifespans. He studies exoplanets, and the physical processes that occur in planetary interiors and atmospheres. And he has authored over 100 referred publications, and he was named as the next physics rock star by Forbes in 2015, under the list of 30 under 30 young scientists who are changing the world. He had his undergraduate degree from UC Santa Cruz and a graduate degree from Caltech, like Mike Roach, and he joined their faculty in 2014. He's been a visiting scientist at the observatory in Nice, France, and that's where he's today. And he's also a postdoctoral fellow at Harvard University. And he's been named a Packard Fellow in Science and Engineering. And in 2021, he founded Lucinetic Incorporated, which is a generative AI company. And in his free time, he moonlights as a singer and guitarist for the rock band, the 7th Season. And at UCLA, we also have a Nobel Prize winner for physics, Andrea, I think, right? Andrea Gee. And Konstantin has worked with her or knows her, and he even plays the band with one of our department professors. So
yeah, that's right. So the real reason I logged onto this call is mostly to advertise my band to you guys. We're trying to get a following any way we can. Everyone in LA is trying to make it in one way or another, and so this is our way.
All right. With that, I'll turn it over to Ian to moderate the session. Please post your questions on the chat. Thank you.
Yep. And thank you so much, Sankar. There's so much for us to unpack today. But before we do, Kate, thank you so much for your time. I always learn something from you.
I really appreciate being here. Yeah.
Good. And one of the things that we were talking about earlier is how some of the terms that we use in project management that are, pretty familiar to everyone, take on a whole different meaning when you look at it from outside your own industry. So what we were talking about earlier was, in project management, we all start out with the discovery phase, right? Trying to see what is the problem? How, what are the things we're talking about? Who's affected by it? Now, I'd love to dig deeper when it comes to your line of work, Kay. When you think about discovery, when you think about problems that you're trying to solve, what is the thought process? How do you guys go about doing that?
Yeah, first of all, that's a phenomenal question, and I'm going to try and answer it to the best that I can. But I think the principal answer is that it is a process that I view as being very distinct from kind of a moment where something crystallizes into being well understood, right? Like the kind of standard notion of science oftentimes is that we sit around, we kind of like do some stuff, and then a discovery happens, right? And of course that's not really how it works. Discovery in virtually all instances that I can think of, particularly, in physics, the subject I'm most familiar with, right, are things that actually kind of get stacked, little by little over long periods of time, and then when they reach a critical threshold, that and kind of that understanding crystallizes. That's when you kind of tend to call it a discovery. But it's important to realize that literally everything, right, including the development of the theory of relativity, which is one of the greatest achievements, of course, of the 20th century, which is attributed rightly often to Einstein, was not really a thing where Einstein was sitting around and just figured it out, right? There was a whole string of scientists that were all brilliant that preceded Einstein, that built the foundations of the theory of relativity, right? Poincaré, Lorentz, there was some other French guy whose name I can't remember, who had a version of kind of magnetogravity, which was a predecessor to relativity. So, the process of discovery is one where the foundations get laid decades before the discovery gets made. And so when I think about, my work and the search, for example, for Planet 9 in the outer solar system, right, we can kind of quantify the discovery of Planet 9 as the moment we see it, we get a picture of it. But of course, we wouldn't be looking for it if there wasn't already gravitational evidence for it. So I don't know if this is a long-winded answer to a simple question. I apologize for confusing you all
No.
on this, but that's sort of the way that I think about it. I think about it as a very continuous, viscous process.
You lost us with the word viscous. No, I'm kidding.
Well, it's like building a building, right? You don't, the process of building, like I'm looking at a castle, right now. And so you can think, okay, when is the castle completed, right? The castle is certainly completed when it's complete now. And surely there's a plaque somewhere that says that castle was completed in some year. But really the foundation of that castle, the idea of having the castle, etc., all of that was worked out years before it was actually implemented. So the process of discovery, I think, in the astrophysical realm is one that's stretched over huge periods of time, right? It's not something where you say, okay, I got it, relativity, next step, GPS, right? It's more like,
Exactly.
more like relativity. I figured it out. 70 years later,
Right.
somebody might use it for something useful.
Correct. Now, 100%. And Mike, feel free to jump in here anytime. Now, talking about discovery, what attracted you of all the things to focus on to study? What attracted you to the idea of Planet 9?
So, generally with solar system research, I was absolutely captivated as an undergraduate when I realized two things. Number one, that something as seemingly immutable and mundane as the solar system had mysteries about it, right? Like that was crazy to me. I remember never quite recovering from this notion that, the solar system of all things was a mysterious place. And that was one. Certainly the other thing that I've sort of had a life, I guess now career long, fascination with is the theory of chaos. But chaos theory in its kind of mathematical, in its mathematical formulation, if you will, is relatively simple. Okay. And it's actually not that much fun to work on the direct mathematical development of chaos theory. It's much more fun to work on the applications of chaos theory. And there's no better test bed for chaos than the solar system itself. Okay, but the solar system itself evolves over long periods of time in ways that are fundamentally unpredictable, and it is one of the greatest discoveries of the last, decade of the 20th century, right? That the solar system itself, the planetary orbits, things that we think of as being very regular over long periods of time, are unpredictable. So I am very attracted to the mathematical nature of the dynamics of the solar system. I don't know why. I've always just loved it. And through that process of just kind of trying to understand the structure of the solar system better, I noticed irregularities. I noticed things that I could not explain. And together with my close collaborator, Mike Brown, who's also a professor at Caltech, who's more of a data guy, we kind of just looked into it further, and we were certainly not like on a mission to discover a new planet. This was not some grandiose thinking. This was just like, let's follow things that don't make sense and kind of try to uncover a little piece by piece what about the structure of the solar system that we're missing, and that's what led us to some of the anomalous like patterns that we see in the outer solar system that point to the existence of Planet 9.
Wow. So going along the lines of project management, okay, you have this idea, we're going to figure out Planet 9. How do you, from that point, go about in making tangible steps, things that we'll implement so that we can get to the end product, which is then the discovery?
Yeah. So I try to always think in very practical terms. How do we break down the problem so that there's a short-ish term goal that is not necessarily the final goal? Like, it's not like, okay, let's discover Planet 9 this week or bust, right? It's not that. It's more like
By Thursday.
yeah, like by Thursday, let's get going on figuring out, a very simplified model of something, right? Of the behavior of debris beyond Neptune in presence and in absence of Planet 9. Let's not put all the physics that is present in the solar system. Let's put, just like the simplest physics first and see how that behaves and understand that. Once you understand that, you build the first layer of foundation. Then you set the next goal. Let's build it upon it in the next level. And so you kind of up your level of sophistication that way. And as a consequence, right, we have changed a lot of the Planet 9 hypothesis over the years. Some of our, annoying colleagues criticize us for this because they say, "Oh, you guys keep changing your mind about like where it is." Like, well, yeah, like we keep doing research, we understand more, and we have no problem saying, okay, our understanding from 5 years ago was actually perfectly incomplete. In fact, it's like when I read some of the work I wrote back then, I'm just like, oh my God, it's embarrassingly dumb, right? But now I understand it better, and here's it is. And then, you reach a critical point where you say, okay, we now have enough understanding to start a search, an observational search, right? Really going to the telescope. And that's a whole other thing, because there you are completely constrained by factors that you do not control, right? They are, on the human side, how much time will you get at the telescope?
I was about to say, yeah.
Right, like everybody wants to use the
Right.
largest telescopes in the world for their projects, rightfully. So you're constrained by that. But at least that is a manageable constraint, meaning like once you know the time you have, you can kind of adjust with the adjust to the schedule that you've been given. The thing that's much more difficult is that you're controlled by random events that happen when you're observing. Like, as an example, when we look for Planet 9, we have to do it in December because that's when you can see it. We have to do it on a moonless night, okay, because the moonlight, of
The
course,
light. Yep.
contaminates it, right? And everything has to go right 3 days in a row, because the way you do it is actually, it's very simple. You take a picture of the sky, okay? I mean, really, you take multiple pictures, but for each patch of the sky, you take a picture and you come back the next day and you ask which stars have moved. And on the third day, you ask which stars which have moved by the same amount. Okay, on the third day, because that differentiates between like asteroids and distant bodies. So on those 3 days, you can't have the weather go bad. You can't have the telescope break, and the telescope breaks all the time. I don't know why. Why can't they just make it work? Jesus. But and like things like turbulence in the upper atmosphere, right? The same turbulence that you feel when you fly on the airplane, right? Like that will completely change your sensitivity limits, because that will cause light to get messed up as it goes through the upper atmosphere.
Right.
So those are the kinds of things that you really can't control. And that, for us at least, that plays the central role in limiting the efficiency of our survey. Our survey in looking for Planet 9 is actually very inefficient. We only get to use about 20% of the data we collect, because the confluence of everything going right 3 days in a row. I mean, think about each one of your lives. Like, when was the last time there was a 3-day, 3-day cycle where everything went right? I mean, probably like when you were 6 years old or something.
I was
right?
about to say.
Yeah.
Before
Right,
I
I mean,
could
there's
get my first
always
bicycle.
something.
Right.
Yeah. I remember there was one time where we were observing, it was beautiful. We were the last night, we were collecting, we were perfect. And then someone, I mean, you guys are healthcare people, so you know that there are people that will get hurt, by doing dumb things. And it was like in the middle of the night, someone decided to drive up to the top of Mauna Kea and either parachute off of it or just like jump off of it or fly. Anyway, this person jumped off of Mauna Kea, got horribly hurt. They had to drive up the ambulance, and then the ambulance had to retrieve this person for hours. And so you could see in our data the like ambulance lights strobing. We're like, wow, all our stars look red every other second.
Those
So
were the aliens, man.
that's right. They were using the ambulance to mask themselves.
That's right.
That's when they were probing. Yeah.
I have one more question and we'll open it up to the group. So as you're conducting these multi-year searches, projects, how do you keep the motivation, the enthusiasm, of the group to keep going, not just weeks or months, but year over year? That's one of the challenges that we have, although in a smaller scale, as project managers, is keeping the team enthusiastic about the end goal.
Right.
And keep at it. So what is your secret sauce aside from rosé?
Well, I've got the rosé, I've got the I've got the beer, I've got all kinds of secret sauces. But yeah, it's a great, I find that this is really the hardest thing, right? Like the thing I've gotten pretty good at these days is picking the right team, right? So I am extremely selective about who I hire into my research group. At this point, maybe I'm like overly cautious, but after being burned enough times, you kind of develop that kind of eye for people who are able to maintain cool, who are not going to freak out when things don't go their way. That's important, undeniably. Secondly, I try to ensure that everybody in the group has their own set of goals, and so that they're working not towards a collective I have like an allergy towards collectivism because I was like born in the Soviet Union and all this, and so like I try to think about it, like everybody's motivated, or people who end up being motivated are motivated by individual goals, right? If they can make a difference in the thing that they want to do, like that's what really resonates. So how do we break up the problem into individual goals so that people can fully take credit for the thing that they've done? Like I always try to, in this regard, for work that I don't lead, like I always put myself last and say this is not my thing, and that seems to work at least half of the time well, to keep people motivated. And the same thing with the AI startup, right? Ultimately, like we're trying to build an artificial intelligence, but that is not a singular goal, right? That problem gets broken up into 1,000 smaller problems. So there's a lot of room for people to feel really accomplished from doing something that works, right? There's something really satisfying about that. So that's the strategy that I adopt.
Cool. All right, guys. We have Professor K here for about half an hour. Love to hear your comments, questions. Mike, I'm sure you have 19 questions queued up.
I don't know if it's 19, but I do have, I just wonder what your theory is, if you have one, on some of the references on the Planet Nine in medieval tapestries and from the Sumerians and such. They have references to it in history. And I remember reading it, but we've not been able to duplicate or find the same evidence.
So there is, I looked into this quite carefully, because like when we first started talking about this, I got all of this, all these emails from people all over the world talking about Sumeria. So as far as I can tell, the Sumerians never actually talked about Planet Nine. This was largely traced back to a 1996 document by some guy talking about the Nibiru cataclysm. Okay, but like, so that is, I've not been able to find any actual Sumerian documents pointing to this, but there are a whole bunch of others. So like, even in the, like, I'm going to butcher this, so I've never read the Quran, but I've been told that the Quran has references to planets 9, but also 10, 11, and 12. So maybe we're missing a few of those bodies. What is all of this? So here's my sense. My sense is that the human beings all over the world share a unique curiosity about the night sky, right? There's something mystical, like there's something that resonates among all of us, right? Like if you go to every culture, right? Every culture has some mythology that explains the motion of the wandering stars in the night sky one way or another. And part of it is practical, right? It was used for navigation and all that. But part of it is just like, I don't know, I've never met, I've traveled all over the world. I've never met anybody who wasn't interested in astronomy, right? Even like anti-science people, right? Who, like have very strong opinions about cell phones and climate change and whatnot, right? Like I've had a conversation with them, and they're very interested in astronomy and understanding kind of our world. So I think it's something that's embedded deeply in our genetic makeup almost, to explore, right? Humans have always explored what's beyond the next hill, beyond the next river, beyond the next ocean. And it truly, the night sky feels like a final frontier. So I think that the speculation that's worldwide about what the night sky holds is kind of a natural consequence of that. I know this is maybe not the answer, not a well-defined answer, but I think that there's something there. You know what I mean? Like it's something innate.
Thank you. Appreciate it.
Yeah.
This was supposed to be a last question I wanted to ask, but I'll ask it right now. Based on your
Okay.
research and your personal opinion or professional opinion, is there life outside of our solar system?
Oh, absolutely. Absolutely. It is, in my view, a statistical impossibility that life does not exist outside of the solar system. And here's why. If you dial the clock back to 1994, the number of planets that we knew of that orbited other stars was 0, unless you count the weird pulsar planets, then it would have been 2. But one way or another, right, at the time when Nirvana broke up, like, we didn't know about extrasolar planets. But today, right, like, the count of extrasolar planets is over 5,000. In fact, my close friend Eric Petigura, who's a professor at UCLA, who is an observational astronomer, like, his business is to discover planets around other stars. And what his work shows is that planets are extraordinarily common, right? Typical, if you look up at the night sky, maybe not in LA, because you'll see mostly an airplane at best. But like, if you go up and look at a night sky in a place with a clear sky, right, at least half of the stars you see in the night sky have planets. So think about that. The galaxy has 1 trillion stars, and there are 1 trillion galaxies out there, right? The planet formation process is so efficient that at least half of those have planets. Is it, like, given that astounding set of orders of magnitude, it's impossible in my mind that the Earth is the only place that has biological life, right? I think the sharper question is, where's the closest one, right? Like, Mars, we know during the first few 100 million years of the sun's lifetime was like the Earth. I mean, we see evidence of rivers and flowing water and a thick atmosphere, right? Even in the cratering record, right? The fact that there are no old, or rather super old craters, means that the meteorites were burning up in the thick atmosphere of Mars. And you might very plausibly imagine that life developed on Mars early in the solar system's lifetime. And since then, as the atmosphere collapsed into the polar ice caps, right, life on the surface has been obliterated. Or has it, right? Because if you go in the Earth, as far as we can dig, right, people dig deep into the mines, and like kilometers down, there's life. There's very, very slow, but there's life in the crust. So I don't know, like, what if there's under the surface life on Mars now, right? That's a great question. I've talked to my friends who are geobiologists, and the point they make is, if life starts, it's really, really hard to wipe it out, actually. Like, I've tried to kill all life in my kitchen multiple times. I try it all the time, every week, and it comes back in 2 days, because the tiniest amount of life that's stuck in the tiny crevice, right, multiplies, and it's very resilient. So, then you go out, moons of Jupiter, right, that have extraordinary oceans under the
Oceans, yeah.
The surface of Europa. Like, is there life there? Like, is that the closest life, or do we have to travel halfway across the galaxy to find them? Like, that's a question I don't have an answer to, and I'm very interested. But I think the question of, like, is there life out there, is one that seems statistically settled, at least to me.
Okay. Just one other question, and then I'll turn it over to others. What is the biggest problem astrophysicists are trying to solve, like top 2 or top 3, in your opinion? Like, there is this topic of dark energy. What is your challenging? What is it the astrophysicists are challenged or trying to solve?
I think the principal problem is how to keep the faculty meeting on rails, right? Because there comes
I can help out with that, Kay.
Yeah. I mean, there comes a time about 3 minutes into every faculty meeting when everything that needs to be said has been said, but it has not been said by everyone. Okay. And then it's repeatedly, we're back to square 2 time and time again. Yeah. I mean, so to to kind of think about the major questions. Obviously, the one of the emergence of life in the universe is a huge one, right? And that's why ultimately planetary science research is so interesting. But you can also undeniably ask the question of what is dark matter, right? What is dark energy? And what happens, inside black holes, right? Where the theory of relativity breaks down a little bit. And I'm also very interested in the questions of emergence and chaos, right? Like, how do planetary systems form, right? Like, what is the origin? How did the solar system originate? That's a problem is a question that's very easy to state, extraordinarily difficult to answer, because it's a problem that touches every scale possible, right? It's from the greatest scale, where the only thing you have to worry about is gravity, to the microscopic scale where quantum mechanics, right, controls the opacity structure of the protoplanetary disk and sets the temperature structure. So the condensing of this first, grains is dictated by literally like how much of some trace element you have in the gas. So it's such a complicated problem that's stretches over 40 orders of magnitude in terms of scale, that I absolutely love it. I do a lot of research on it, and I think that towards the end of my career, we'll have a better answer, but we will not have the answer.
Thank you.
Someone just logged off when they heard this. They're like, I'm done with this. This talk is the worst. I was hoping for the answer, and this guy says we won't have the answer. So
By the end of his career. Any books around chaos theory that you like? One I like is the one by James Gleick. You probably read that one.
yes, that's a great one. Yeah, that's a fantastic one. Yeah. I also like this. There's a book by Strogatz.
Oh, Strogatz. Yeah.
So there's like a popular science book called Sync, which is very, very easy to read, very kind of engaging. There's a slightly more complex book called Nonlinear Dynamics and Chaos, but that one I can also recommend. Like, you don't need to be a great mathematician at all. You just need to like kind of know algebra, maybe like a very basic calculus, but it's a very, very chewable book. I love kind of reading that text. So
that's by Strogatz, right? The nonlinear.
There's also Strogatz. Yeah, he's a great teacher. Yeah, he's a mathematician, a Cornell, great instructor.
Well, I'll throw in some of the books you mentioned in the chat for those who are interested in chaos theory. But guys, please feel free to ask
questions. Can I ask a selfish question?
Go for it, Eric.
First of all, thank you very much. Ian's like, you got to attend today's session because you have the life that I wanted to lead back when I started. Like, you're literally living my dream life, especially at Caltech. So since I didn't make it, though, my son is on a great path, and he's going to be applying to Caltech as well. He's got one more year of high school. So maybe talk a little bit about your journey through, and especially you came in through the UC system at UC Santa Cruz, and then ended up at Caltech, and you're young, promising gentleman, at least compared to me. What advice do you have for those kids like my son, who are getting into a very challenging world? Like you mentioned, AI, the job, the competition. Every little thing has to be fought for, right? At this point.
Yeah. Oh my God. Yeah. I'm so glad you're asking.
Can I give you his resume?
Yeah, that's right.
Look, so I think a lot about this, also with my kids. I've got an 11-year-old and a 6-year-old, and I think about the world that they are walking into, which is a world, of checked boxes and, kind of like, test scores and all of this. And then I think back to myself, and I like, so first of all, like sorry, I'm going to close the door so that the kids don't hear this. But like, you know, in middle school, I fucked up completely, right? Like I was just like chain smoking all day, getting into fights and just playing guitar, and just like I was the perfect example of somebody who was on the wrong track. And this was, you know, I was in the time I was living in Japan. So like my trajectory is, I was born in Russia, but like when I was 8, we moved to Japan because my dad found a job outside of Tokyo. So I grew up in Japan. And yeah, I really, really hated the drift of the kind of Japanese kind of the school and the upbringing of just like academic excellence continue, right? I really felt that was something very frustrating. And coming to the US was a great transition for me, frankly, because it was the first time that no one cared, you know, how well you do, right? Like it was kind of like, well, you can do this, like you can do construction if you want, you can do not gonna. I actually worked as a construction worker in high school, and that was also a great lesson in figuring out that I didn't want to be a construction worker for the rest of my life. And yeah, like that was the thing that turned me onto a somewhat different trajectory. And I was, you know, 18 years old at the time. And I'm also really quite happy that I didn't go to Caltech as an undergraduate, right? I went to UC Santa Cruz. Like if I had gone to Caltech, I was not prepared for the for just like the level of rigor and the rate at which, you know, our undergraduates are expected to absorb information. UC Santa Cruz was the perfect you know, avenue for me, where I kind of got my bearings. I started to kind of get a little bit of wind under my wings, and then I got involved in research as an undergraduate, and that's when it really clicked. And so the only reason I got into Caltech for grad school was not because of grades, because like my grades were not terrible, but they were sort of at the 3.5, you know, GPA level, floated by classes like music of the Beatles, and you know, where you could really score that A+. You know, but, you know, like I was spending, you know, with my band, we were touring all over West Coast all the time. And so I was always like doing homework, you know, in like literally a toilet of some bar, you know, in Barstow, right? So it was just, it was a lot of fun, but I guess the point I'm trying to make is that there is not a singular trajectory. I think that the kind of world that we're developing now, of like, you know, make it or break it, you have to constantly score at the highest level. It's not actually the real world, right? If I think about a lot of my colleagues, right, a lot of them have had kind of weird, some of them went the full up academic route the entire time, excelled all the time, and others were, you know, a little bit more nonlinear. So there's more than a single way to get there, and so I'm optimistic that this will remain the case, frankly, especially as artificial intelligence comes into its fold. The transition will be difficult, but my kind of long-term hope, frankly, is that as it replaces a lot of the mundane work that we do, you know, hopefully there'll be a little bit more room for our individualities to shine through, right? And that would, imagine that, like that would
a
be
very Roddenberry view of the world, but
yeah.
very, very, very good. So what's the one piece of advice? What should I tell my kid? Like what's
yeah.
the big advice that I should go back and say, oh yeah, this guy I spoke to today said do
Yeah,
this.
I think to stay curious, right? This is what my parents told me. Like my parents never pushed me to do any particular thing. They just said, find the thing that you really are curious about, and then just do it, and then just be really go in it 100%, right? Like stay, and it doesn't matter what it is. And it so happened that for me that was astrophysics, but it could have been something else. And everything can be interesting once you go deep in it. So I think that finding that resonance, finding that curiosity in a particular subject is way more important than scoring really well across the board, right? As being a faculty member, at the Institute, like when we accept graduate students, I'm always so much more impressed by someone who's done something really meaningful in a narrow, range of expertise, something that they really, really care about, as opposed to someone that's just generically good, right?
That's good advice.
And you can send the resume to me, Eric, and I'll bring it up to Kay after a few
Yeah,
beers.
no, send it my way for sure.
With some French fries and
Well, I guess he has to
ketchup
have
stains.
a job first. He's been in school. He's one of the studious kinds that actually does have a very high GPA and a very high score. So I told him, as long as you keep that up, you don't need a job. But now he wants my car, so we got to talk about that. That's his,
Well,
And Eric, when he gets into MIT, you have to tell him exactly what you did for my kids then.
oh yeah, I mean, listen, if,
You
whatever.
gotta share that knowledge, okay?
I have to. Let's see what he gets into. Like
No
I said,
pressure, Eric.
I mean, listen, I toured USC too, just not to give some credit to our crosstown rivals, but their program was also very, very impressive. So we're lucky in Southern California to have so many, options. But I did put my foot down. I said, if he gets into Caltech or MIT, he's really not going to have an option but to attend, even if I have to work 3 jobs to do it.
Look, I mean, I have to say, the Caltech experience, I think it would not have been right for me, but for somebody who's very academically inclined early on, I mean, I didn't appreciate how good the program is until I became a professor, right? I mean, the students that come out of Caltech really know what they're doing. Even the kind of, not the top of the flock ones, they come out of Caltech and then they're kind of like, they realize that they're still kind of in the upper echelon at the at their hedge fund or whatever. And so yeah, it's a great program. I can highly recommend it.
There you go, Eric. Now you have a reference.
All right. I'll have to get his email address after this. I have to sneak that into me.
All right. Any other questions, guys?
I can ask one more question.
Go for it,
So-
Sankar.
So Konstantin, so when you have a research project, do you think like it's a project like, you said you have limited time with the telescope, you have to hire a team. It's all, you pretty much do a lot of the things that we do for a project, but yours is a research project. And how do you go about, managing the scope? Are there new scopes added? And where does your budgeting come from? And can you talk from a project management perspective of the work that you do?
Yeah, it's always a tightrope. I mean, I try to walk it the best I can. A lot of my funding comes from either National Science Foundation or NASA or private foundations like the Packard Foundation, the Sloan Foundation, or the Heising-Simons Foundation funded my postdoc, Juliet. She just left and is starting a faculty job at University of Wisconsin. So it's always, a process of trying to kind of play that game. I don't have a formula, so to speak. I'm trying to be maximally opportunistic from a funding point of view. And I also try to not let funding ultimately control the idea. Like it controls the scope of the project, but one of the things I try to separate in my mind is the thing that I want to go after and the question of whether or not there's money available to it. I bypass a lot of opportunities where there's money available but it's not interesting, right? Try to go at things that are interesting and then think to myself, okay, if I go after this, I'll figure out the money. Like I'll somehow make it happen. That has worked relatively well, at least so far. Maybe this is the year that it all collapses and the house comes crashing down. But so far I've been able to kind of follow my nose and figure out the details later. Ultimately, there's money laying around here and there, right? It's not that, at least for me, I try to not make that be the determinant of what I do.
Okay.
And Christopher enjoyed Liquid Water. Now, Liquid Water is the 2007 album of our band, but I'm guessing what Christopher is referring to is Just a Drink.
Christopher, you want to pipe in here?
I was listening to the song earlier.
All right. Oh my gosh. Well, with you listening to it, our Spotify, our Spotify rating is up.
Went up by 1.
Yeah, that's right. Which is a lot for us. Actually, I have to say, like, with our band's been, we've been putting out these new records, and I don't know how the algorithms work now, but we are, new people are discovering us, and occasionally, like sending us nice messages about how we sound like an 80s metal band, which I take totally as a compliment. And I don't know, it's just great. This is great. I'm not trying to and will not make any money on music, and that's perfectly okay. But it's a lot of fun to do it in today's world. Like, the reach that you can have with the distribution that's available is so different from what it was 10 years ago or 15 years ago.
Vivek, you had a question.
Yeah, it was just something I picked up. So did they still play the Ride of the Valkyries when you were at Caltech?
They do, yeah. Before the finals,
They still do?
sure do.
Did you go to
Yeah,
Caltech,
nice to
Vivek?
hear.
I didn't know that.
I heard it from Mike, actually.
Yeah,
From Mike.
yes, that was a tradition then. It's a tradition now.
Yeah, it's a good one. Yeah.
We have 2 minutes left. Any questions before we adjourn? So, Konstantin, so final piece of any advice for us from a project management perspective, multi-year project, scope management.
If you guys find Planet 9 before I do, you guys gotta let me know. All right, that's my advice.
We'll help you out. We'll add it to the NPR Sankar.
Yeah, there you go. I don't know what NPR is, but add
A
it
new
to it.
project request.
There you go. Yeah, but like top of the list. Yeah.
Yeah.
Yeah, we do have something called project change request. So we start a project, and if we find something that we need to get funding or resources, we have the project change request process. I think that's what you kind of explained, that you somehow
Mhm.
get additional funding and resources. So thank you very
Yes.
much. Yeah, go ahead.
No, thank you all for the logging on and hanging out with me, and I really enjoyed the conversation.
Thank you very much. We very much appreciate your time
Yep.
and talking to us today.
Yeah, and
Thank you very much, and
I
for all
think-
the advice.
Thank you.
I think you're getting some more new band followers.
Oh, there you go. 2 more on Spotify.
Okay, let's.
I don't have Spotify.
Great.
Thanks, Kay. I'll
Thanks,
catch you
everyone.
when you're back.
All right,
Thanks,
sounds
everyone.
good.
Have a
Thanks.
good rest of the afternoon. Bye-bye. Thanks once again.